let's move to the next segment. And in this one, we are going to talk about nearest neighbor classifier. It's a very simple classifier, and I think you will have a programming assignment for this as well. Okay, so let's quickly go over this, and you can see the name. It says nearest neighbor, right? And that's all the algorithm actually does. It just tries to find the nearest neighbor. So here's the idea. You have your training samples, right? And sorry about that. Okay, so these are your training samples. And you know that you have two different classes. Blue boxes is the first class, and red circles, that's the second class. And again, so think about this as you are projecting your features from these samples onto the Euclidean space, which means each of these point could represent like an image. Okay, and it could represent anything, like depending upon what problem you are solving. So let's say if this is an image, then you can extract features from that image, and then you can perform like some kind of dimensionality reduction. So don't worry about that. It's like an algorithm which maps your high dimensional feature space to small dimensional feature space, and PCA is one good example. We saw that like in I think the second lecture. And autoencoders is again, I mean, you can project it to a smaller dimensionality space, right? So consider that the case, then you are projecting that into two-dimensional space. And once you have two-dimensional space, you can actually just plot that on this Euclidean space. So each of these points could be an image. Okay. Now, how this nearest neighbor works, you take your testing sample. Okay, so the good thing about nearest neighbor, you don't have to train any classifier. Okay, so that saves your training time. The only thing you have to do is extract features. Now, you take your testing sample, and that testing sample, again, you will extract features, you will project, you don't have to project into this low dimensional space. You can actually work on high dimensional space as well. We will go to that later. But let's say this testing sample lies somewhere here. Now, if I ask you like, okay, to which category this sample belongs? So as a human, what will we do? We'll just see that, okay, I mean, this seems like it's closer to these samples, right? And it's far away from these red samples. So most probably this is a blue sample. And so that's the intuition. What we do is we compute the distance between this sample to all the other training samples. Okay, you will compute with this, and all the red samples as well. And then you can just sort all those distances. And whichever distance is the shortest, you just pick that class. So in this case, if this is closest to this blue sample, it seems like the closest one, then you say that, okay, this sample is from blue category. You just assign that blue category to this test sample, and that's it. That's your nearest neighbor classifier. All right. So now what I showed you is like projected on this two-dimensional space. But now let's think about, let's say you extracted features, and that feature is, let's say, 1,000 dimensional long. So you don't have to project, just compute distance in that 1,000 dimensional space. It's just like a L2 distance. You can use actually any distance, cosine distance, L2 distance, L1 distance. The results will not change like depending on the method you use for computing distances. Okay, so you can compute distance in that high dimensionality space, and you just pick like the sample which is the closest and assign the class to the test sample, and that's it. In this case, that's the class. Okay, so that's the nearest neighbor algorithm. And as I said, it's pretty simple. And we don't need any training. All we have to do is extract features and compute distances from the test sample to all the training samples. Okay, so that's fine. I think we can skip the slide. Now the question is, what will be the decision boundary in case of neural networks? Because what we are doing is, given a testing sample, we're computing distances from all the training samples, right? So it turns out this is kind of a Voronoi plot, okay? And the way it will look like is what's happening. So the red dot is like class number 1. The black dot is class number 2. Now, if you divide this whole space into like different categories based on distances, then all you have to do is you just divide two different samples. Okay, divide the space between two different samples. So this is a sample number 1, this is sample number 2, and this is like the line perfectly dividing these 2 points. Okay, so any point which is on this line, it's kind of equally distant from these 2 points. But if that point is towards black, it's black category. If it's towards right, that's red category. Okay, so you do that for all the pair of samples, and that will give you this Voronoi plot. Okay, and you can just like do it manually. I mean, okay, so that's how the decision boundary will look like. And now what you can do is you can take any testing sample, and just depending upon like where it lies, in which regions it lies, you can just tell the category. For example, if it's on this block here, you know it's a black dot. If it's on the gray region, you know it's the red dot. Okay. And again, this is like just 2D. And again, that's in 3D space. Of course, you can extend similar kind of partitioning to n-dimensional space as well.